Hi, in this video, we are going to continue on the Form 3 to Form 4 transition course, and this will be the last video. And here we will be talking about some common chemical reactions, and later on we will talk about how we can write down observations based on the chemical reactions. So let's get started. Now here, it shows you some common types of reactions. Some are more important than the others. I will let you know later. So let's start with the first one. The first one is called combination reaction. Basically, we have two elements react together to form a single compound. For example, sodium reacts with chlorine to form sodium chloride. Here, two hydrogen reacts with oxygen to form water. Now, the first equation is not balanced. You should have two NaCl and two Na. Okay? And these reactions will release a lot of heat. Now for the second type of reaction, it is almost like the reverse of the combination reaction. It is called decomposition reaction. This time, we have a single compound decomposed into elements or compounds. It could be two elements, it could be three elements, it could be a bunch of different elements and compounds. Okay? So the first one here, this is the thermal decomposition of silver 1 oxide, and this is also how we extract silver from the ores. Okay, so they form two elements, silver and oxygen. The second one is the thermal decomposition of calcium carbonate, also known as limestone. This time it forms calcium oxide, which is a compound, plus carbon dioxide, which is also a compound. So these reactions often requires heating or exposure to sunlight. It requires input of extra energy. Okay? Now, the third one, combustion. This is important. So for combustion reaction, we have generally a fuel reacts with oxygen to form carbon dioxide and water. Example would be methane. Methane is a flammable gas found in the town gas. Reacts with oxygen to form carbon dioxide and water. This one is glucose, okay, a type of sugar. When it reacts with oxygen, it forms carbon dioxide and water. So these combustion reactions release large amount of heat. Now the third type of reaction, neutralization, this is also important. You should have learned it in Form 2 science. We have acid reacts with an alkali to form salt and water. And these reactions will release heat. Okay? This one is hydrochloric acid. This is sodium hydroxide. Sodium chloride is definitely a salt. Water is water. Now the second one here, we have sulfuric acid neutralizing with sodium hydroxide. This time, it forms sodium sulfate and water. Now sodium sulfate is also known as a salt. Remember, salt in chemistry is not simply talking about sodium chloride. To tell the difference, or very often, sodium chloride will say that it is a table salt. In chemistry, salt basically means all the ionic compound formed from a neutralization reaction. Okay, so sodium chloride is a salt. Sodium sulfate is also considered as a salt. Now down here, displacement reaction. Now there are two types of displacement reaction here. So the first one, you see the general equation. Metal reacts with metal ions to form metal ions and metal. Basically, we have the metal here at the end forming metal ions. On the other hand, the metal ions as a reactant will become the metal. So you notice that the red metal and the blue metal kind of exchange their identity. Metals becomes ion, ions become metal. So the metal takes the place of the metal ion to become an ion. So that's why it is called displacement reaction. Okay? Example will be here. Zinc reacts with copper 2 sulfate to form zinc sulfate and copper. Okay? We say that the more reactive metal will displace the ion of a less reactive metal. So here, zinc is more reactive than copper, so zinc can displace copper 2+. So it will form zinc sulfate and copper metal. However, if you put copper into zinc sulfate, no reaction takes place. Okay? Now, this displacement reaction also takes place in halogens. So you see we have a halogen reacting with a halide ion. Halide ion basically means the negative ion of a halogen. So that could be fluoride, chloride, bromide, iodine. Okay. Now the halogen reacts to form a halide. The halide is reacted to form halogen. Okay. So you see chlorine reacts with NaBr to form NaCl and Br2. Now, obviously, chlorine is more reactive than bromine because you remember group 7 elements, the reactivity decrease down the group. So chlorine is more reactive than bromine. Bromine is more reactive than iodine, right? So chlorine is more reactive than bromide. So chlorine can displace bromide to form chloride and bromine. Okay. However, bromine is unable to displace chloride. Okay, because bromine is less reactive than chlorine. Okay, that's the idea about displacement reaction. Now down here, these are acid-base reactions, also important. Basically, any reactions with acid besides neutralization, besides acid and metal. Okay, so metal oxide reacts with acid to form salt and water. Okay, metal carbonate, metal hydrogen carbonate, both can react with acid to give you 3 products. Give you a salt, give you carbon dioxide, give you water. Okay? Now you may notice that most of the reaction involving acid with metal or metal compound will give rise to a salt. Okay? And with carbonate and hydrogen carbonate, they will give you carbon dioxide. Okay? And they will also give you water most of the time. Okay? And this reaction will give out heat. And when you have carbon dioxide given off, you will see effervescence. Effervescence basically means bubbling. Okay? Bubbling. Okay? Next page. So the last item here is talking about how to deduce observations from chemical equations. So first of all, observation. We have been talking about observation since Form 1. Again, observations is what we can see, what we can hear, what we can smell, what we can feel when a reaction takes place. Well, taste is not advisable because we should not taste anything in the chemistry lab. Now, these are some common observations. I copied it from the Form 3 note. So very often, observation includes a solid dissolves, formation of bubbles, generation of heat, color changes, as well as the formation of precipitate. Precipitate is a solid form when we mix 2 solutions together. Okay? Precipitate is something insoluble. Okay? Now, let's see how it works. Let's just say we have an example. Calcium carbonate add into hydrochloric acid. So this reaction we have learned in Form 3. Calcium carbonate reacts with HCl to form 3 products: a salt, carbon dioxide, and water. Now, how can we deduce observation? Now, first of all, we look at the reactant. Now, you see the reactant side here. Calcium carbonate is a solid. And then this one is aqueous, it's a solution. And you also look at the product, aqueous, gas, liquid. That means a solid mixed with a solution. And at the end, we do not have any solid left. So what does it tell you about observation? Well, it tells you that the solid dissolves. The solid will dissolve in the solution. Okay? So you see the first observation is white solid dissolves. Now when we talk about solid dissolves, it would be best if we can include the color of the solid. Calcium carbonate is white in color. Now some of you may say, hey, can I put down calcium carbonate dissolves? Can I put down calcium carbonate dissolves? This one is not recommended because observation, we are describing something that we actually see. We are describing the most authentic things that we can observe from the experiment. From the experiment, what we actually see is the white solid dissolves. We didn't see anything called calcium carbonate dissolves. The chemical doesn't carry a name on itself. So it would be best if you write down the most objective observation. Okay, white solid dissolves. Okay, now this is the deduction. Now in exam, very rare does the question ask you about the deduction. But this one is to tell you how I come up with this observation. It's by looking at the physical state of the reactant and the product. And from there, I'm able to deduce that, oh, the solid dissolves. Okay? Now down here, because it produced carbon dioxide, and the carbon dioxide is produced from a solution. Okay, the solid add into the solution, and then we see a gas given off. And carbon dioxide is soluble in water, but it's not very, very soluble in water. Therefore, we will expect to see bubbling occurs or effervescence occurs. Okay, carbon dioxide produced underwater, and carbon dioxide is only slightly soluble in water. Okay, now if the gas produced is very, very, very soluble in water, such as ammonia, such as sulfur dioxide, such as chlorine, then we might not be able to see the bubbles. For chlorine, we may see the bubbles, but definitely not ammonia and sulfur dioxide. Okay, so you also have to pay attention whether the gas is very soluble in water or not. Okay, so these two are the observations. Now, also look at the second example. This one we haven't learned this reaction. So, but let's see if we are able to deduce observation simply by looking at the equation. Now here, copper 2 sulfate reacts with sodium hydroxide to form copper 2 hydroxide and sodium sulfate. Okay, and the scenario is that sodium hydroxide is added into a test tube, and the test tube originally contains the copper 2 sulfate solution. Okay, now if you look at the reaction, you see AQ, AQ, solid AQ. So you can tell before the reaction we have solutions only, but after the reaction we have a solid. So you must be able to tell that a solid is formed. Now, the solid is formed by mixing of two solutions. So this solid, we will call it precipitate. And knowing that copper 2 hydroxide is a blue precipitate, then we should put down blue precipitate is formed. Okay? Blue precipitate is formed. Okay? Now, the second observation may be difficult to tell. Here, the solution changes from pale blue to colorless. Because if you notice that copper 2 sulfate is actually blue in color because it contains the Cu2 plus AQ. And Cu2 plus AQ is blue in color. So as the reaction takes place, the blue Cu2 plus is converted into a blue precipitate. So the precipitate definitely not soluble in water. So that means as the reaction proceeds, the concentration of Cu2 plus AQ decrease to the point it is used up. Because you see, we add the sodium hydroxide until excess. So at a point, all the Cu2 plus will be consumed. So when there is no more copper 2 plus, when we only have copper 2 hydroxide precipitate, sodium sulfate, which is colorless, and also excess sodium hydroxide, then the resulting solution should be colorless. So that's why when it comes to color change, we will say that the solution changes from pale blue to colorless. Okay? So this is how we can deduce the observation from the equation, looking at the physical state, looking at the color of the chemical reagent itself. Okay? Now at the back, we have again some practice question, and this is the last practice question. I can do some examples for you. Now the first one, so zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. Now, the first thing that I can see is that I see zinc metal as the reactant. And at the end, we don't see any metal left. So that means a solid will be disappeared, well, seemingly disappeared after the reaction has completed. So the first thing I would say is that we will say the silvery solid dissolves. Again, you should not say zinc metal dissolves because we put down the most objective observation. Another thing that I am able to see is the hydrogen gas. Because hydrogen gas is formed from a solution, And hydrogen gas is insoluble in water, so it will form bubbles. So the second observation is bubbling occurs. Okay? Now, also I'll double check to see if zinc chloride is having a color or not. Because if zinc chloride has a color, then I will put down the third observation. The solution changed from colorless to the color represented by the metal ions. But knowing that zinc chloride is colorless, so I do not have to put down any observation. Okay? So, I will leave these questions for you. And down here, basically, you are asked to first write down the chemical equation, and then you state the expected observation. Now, questions like this is very similar to the DSE level. So in the DSE exam, you are probably able to find questions like this. And I would say these will be the most challenging questions for this exercise set. Okay? So do try yourself and check the answers. And that's it for the transition course. Hopefully, it will help you with your Form 4 studies. Bye-bye.